Welcome to the video on foundation design. So in this video you'll learn how to design a foundation using Skyfi software. Before that you need to form a problem statement. So this is the data I have gathered from the previous video of tall building design. So the safe bearing capacity of soil is 300 kN per meter square. The allowable settlement is 1 centimeter. The column material is M40 and HYSD 500. Column details, that is column number, dead load, live load, and the section which is used for that particular column. So this table I have formed from the Model Explorer results from ETAP software. I'll show you how to form this table and from where to collect this data. So the subgrade modulus is calculated using this formula SBC upon allowable settlement. So I have converted this 1 centimeter into meters, and I have calculated the subgrade modulus as 3 into 10 to the power 4 kilonewton per meter cube. The design strip is calculated using 0.25 L, where L is the minimum length. Here the plan length is 18 by 18, so 18 is the minimum length. So 0.25 into 18, we get 4.5 meter. I have considered 4 meter. You can even consider 4.5 meters. So now I'll show you how to carry forward the results from ETAP software for the foundation design. For that we need to analyze the results and analyze the column loads and the column sections which we have used in the design purpose. So for that you need to go to Model Explorer, tables. In that you need to go to analysis. In that you need to go to results. In that to the frame results, select the column forces. As we are going to design for the loads which are coming on the base columns, select the station as 0 station. So select the filter as sort ascending. And after that select the story as story 1. So in load combinations or load cases, select the dead load. So I have collected the data from here. So for story 1, column 1, this is the dead load. We are going to consider only axial load. So consider P and not V2, V3 or the moments. So P is the axial load coming on the column. So for column 1, this is the axial load, and respectively you'll get when you scroll it down. Similarly, go to live load. You'll get the live loads. After that, go to model assignments, frame assignments, go to frame assignment summaries. From here you will come to know the column sections which are assigned for that particular column. So in this case, C1 has been assigned a column section of 500 by 500, C2 has been assigned column section of 600 by 600, and respectively. So here we can see that column C1, C13, C4 and C16 have 500 by 500 column section, and rest of them have 600 by 600. Using those results which I have shown earlier, I have formed this table. So here column 1 has a dead load of 1597.71 kilonewton and live load of respective which is shown in this table, and column section 500 by 500. So you can see that C1, C4, C13 and C16 have 500 by 500 column section, and rest of them have 600 by 600. Now let's start the foundation design. For that we need to go to File, New Model. In this, select the design code as IS456-2000. Set the design preferences as per IS456. In that, set the minimum cover. That minimum cover for foundation is considered as 50 mm, and the preferred bar size is considered as 22 mm. So set these preferences. OK, and select the grid only option. Now as we have seen that plan is of 18 meters by 18 meters, so we need to select 19 grid lines with 1 meter spacing in both the directions. Click on OK. So once the grid is formed, now we have to define various properties. So go to define materials. In that I have already defined M40 and HYSD 500. So we need to change the weight per unit volume, modulus of elasticity, Poisson's ratio, and the thermal expansion coefficient for that particular material, and the FCK value. So I have made the respective changes. Okay. Similarly, add HYST 500, change the weight per unit volume, modulus of elasticity, and FY and FU values for HYST 500. Do not forget to select material type as rebar. So click on OK now. So I have defined the materials now. After that, define the slab properties. So in that I have defined the mat footing. In mat footing, I have selected the analysis property data type as mat and the thickness as 900 mm. Okay. Define the column properties. Although there are 16 columns, but columns C1, C4, C13 and C16 have same column sections, that is 500 by 500, and rest of them have column section of 600 by 600. So we need to define only two column sections, which I have already defined, column 500 by 500 and column 600 by 600. So click on OK. Now define the soil subgrade property. In that, go to modify and change the initial value or the default value to 3 into 10 to the power 4, which we have already calculated. Okay. Now go to define, go to load combinations, create these two combinations. The initial combination, that is combination 1, is for ultimate load or for ultimate case, and the combination 2 is for the serviceability. So combination 1 is combination where the scale factor for dead and live load is 1.5. Select the design selection as strength or ultimate. Click on OK. After that, select the combination 2 or add it, modify. In that, select the dead and live load factors as 1, and do not forget to select the design selections, which is for serviceability. Click on OK. Okay. Now we have to draw the properties which we have already assigned. So go to draw. Select the draw slab options. Make sure that the property type is selected as mat footing. So draw the footing or the slab. So now the slab property is added. We have to extend this plan area for the footing area. Whatever we have drawn, this exists only for plan area. So we need to extend it by 2 meters or by 3 meters from both the directions. So here I will be extending it by 2 meters. So for extending this, I have selected the area. After that, go to edit areas. In that, expand or shrink areas. Give the offset value of 2 meters, that is 2000 mm. Okay. Now this is the actual footing area. Now we have to draw the column. So go to draw columns. So here property below is none, property above is selected as column 500 by 500 and height above is selected as 2 meters. So column 500 by 500 exists for C1, C4, C13 and C16. So I will be assigning or drawing those columns. So these are the columns from the plan I have shown earlier. So this is C1, C4, C13 and C16 column. So now draw the rest of the columns. So rest other columns are of 600 by 600. So I will be drawing it. Now all the columns have been drawn. Do not forget to press escape whenever you draw any entity or any property. Now we have to draw the design strips. So go to draw design strips. Remember that design strip of strip layer A is in X direction and design strip layer B is in Y direction. And here the width we have calculated was 4. So put those values here. And start drawing the strips between the columns from the center to center of the column. So this is the design strip A I have drawn. So you can see this pink line passing through the center of column. This is nothing but the design strip. So I have drawn the design strips for layer A. Similarly, you can draw the design layer strips for B in vertical direction. So you can see I have drawn the design strip layers for A and B. So after that you have to assign the soil property. So click on the foundation. So you can check whether you have selected a proper property or not. So here one area and 4 edges is selected. So I have selected the slab property. Now I'll assign the soil property for that slab. So go to support data, soil properties, select the soil one which we have assigned earlier. Okay. So now the soil property has been assigned. After that you have to change. So change this rebar material for the design strip as HYSD 500. Similarly change the rebar material for strip layer B. Here you need to change this. Okay. Now we have to assign the loads to the columns which we from the data which we have collected earlier. So I'll select column 1. So assign load data, go to point load, assign the dead load. So the dead load for column 1 was 1597.71 and select the punching shear area as 500 mm in X and Y direction, which is nothing but the column section. Click on OK. Now similarly select the previous selection, go to assign load data, point load, select the live load, change the live load value to 718.13 and keep the punching shear area as 500 mm by 500 mm. So similarly add the loads to all the columns from the data which we have collected. So now we have assigned all the loads. After this you need to go to run analysis. So these are the analysis reports. After that go to run analysis and design. These are the displacement values and this is the deformed shape. You can use the color codes to get the displacement values. Now to check whether the foundation is safe or not, go to display, show punching shear design. Now here our punching shear design for the inner columns is greater than 1, which means below this column has been failed. So we need to increase the thickness of the foundation. So first unlock the model. Then go to define slab properties, mat footing, modify the property. I'll use 1200 mm. Okay. Okay. Now run analysis. After running analysis, go to run analysis and design. Now check the punching shear ratio. Now the punching shear ratio for all the columns is less than 1, which means that our design is safe. So you can click on any column and here you'll get the punching shear check and design for that particular column, and you can change the combination here. So this is for combination 1. Similarly you can view the strip forces. I'll select combination 1 and strip layer A and shear forces. So as you move from left to right, at that particular point you will get the shear force for strip layer A. Similarly you can check for strip layer B. So these are the shear forces value. Now you can check the movements also. So these are the bending moment values. So in this way, you can design a foundation. Just we need to keep in mind that the punching shear ratio for every column should be less than 1. If punching shear ratio exceeds 1, you need to increase the thickness of the foundation. Thank you.